Hello dear students of plus one, medical and non-medical, respected teachers. So today I am going to discuss again a very important theorem known as Torricelli's theorem. So Torricelli's theorem is derived using Bernoulli's theorem. So Bernoulli's theorem I have discussed in previous video. So now what is Torricelli's theorem and what it states? Now, suppose we have a large tank containing water, maybe fluid, liquid or gas, large tank containing water, having a fine hole at certain height from the bottom, known as orifice. Then liquid, when orifice is open, liquid starts coming out of the orifice. So the velocity of the liquid or fluid through an fine orifice is known as velocity of efflux. So Torricelli's theorem states that the velocity of a flux, that is the velocity with which liquid or fluid comes out of an orifice in a large tank, the velocity of a flux of a liquid through a fine orifice in a tank is equal to the velocity attained by the body falling freely from the top of the liquid to the orifice, that is through the height between top of liquid and the orifice. The velocity attained by the freely falling body under the effect of gravity is same as that of velocity of flux. This is known as Torricelli's theorem. So velocity of flux is equal to velocity of body falling freely through height h between the top of the tank and the orifice. So to prove this theorem, suppose we have a large tank and capital H is equal to height of the liquid inside the tank. So on top of tank is open and there is atmospheric pressure surrounding the tank. Let H dash is the height of the orifice from the bottom. H is the distance between top of liquid and the orifice. So that H plus H dash is equal to capital H. When this orifice is open, liquid starts coming out with the velocity known as velocity of a flux, VE. P is the atmospheric pressure outside this. So then liquid follows the parabolic path like a projectile. So it strikes the ground and the distance of the point where liquid coming from the orifice strikes the ground from the bottom of the tank is known as horizontal range, and time taken to by the liquid to reach the ground after coming through the orifice is known as time of flight. Now suppose here is point A, top of the liquid, and B correspond to the height of the orifice. Now applying Bernoulli's theorem between A and B. Now as tank is large, when orifice is fine, liquid is coming out of the orifice with the velocity of a flux. So what velocity just above the top will be nearly zero. P is the pressure and potential energy will be rho gh. Therefore, by applying Bernoulli's theorem between points A and B, so we have by Bernoulli's theorem the sum of three energies P, pressure energy per unit volume, plus 0 because velocity is 0, so kinetic energy per unit volume on the top is 0, plus rho gh, total potential energy, is equal to, here again P pressure energy per unit volume, half rho v square, v the velocity, so half rho v square is the kinetic energy per unit volume of the liquid coming out, and rho gh dash is the gravitational potential energy per unit volume. So PP cancels. So we have rho GH is equal to half rho V square. Rho G, instead of H dash, we write H minus H, because H dash is equal to capital H minus H. So simplifying it, rho GH is equal to half rho V square plus rho GH minus rho G small h. Rho G capital H cancels. So transposing, we have half rho V E square is equal to rho GH. Rho cancels, or V is equal to under root 2 GH. So velocity of a flux of the liquid or a fluid through an orifice is equal to square root of 2gh, where g is acceleration to gravity and h the height of the top of the liquid from the orifice. Now, suppose a body falls freely under the effect of gravity from top of a liquid. So when body falls freely, initial velocity is 0. And suppose it attains velocity v by reaching the point O. Then using v square minus u square is equal to 2gh for the freely falling body. So we have v square u0 is equal to 2gh, or v is equal to under root 2gh. So which is same, 1 and 2 are same. Means velocity of a flux of a liquid or a fluid through an orifice is equal to velocity attained by a liquid falling freely under the effect of gravity. So this is nothing but Torricelli'S theorem. Now, to find time taken to reach the ground by the liquid, time of flight, and horizontal range. So using formula h is equal to ut plus half gt square for a body falling freely under the effect of gravity. So h dash is equal to, now height of orifice is h dash. Liquid falls through height h dash. So h dash is equal to initial velocity in the vertical direction is 0 plus half gt square, or t is equal to under root 2 h dash upon g. So this gives square root. This gives time of flight, time taken by the liquid to reach the ground after coming out of the orifice of the tank. How to find horizontal range? Horizontal range is equal to product of velocity in the horizontal direction into time of flight. So velocity of flux under 2gh under 2h dash upon g. So under root g cancels. So we have 2 r is equal to 2 under root h dash. This is known as horizontal range. So we can use this formula for numericals. So this is all about Torricelli's theorem, and again it also uses conservation of principle of conservation of energy. So potential energy is being converted into kinetic energy. So this theorem is very important because it is one of the applications of Bernoulli's theorem. All the best, be happy, good luck, stay tuned for next video.